All right, so I want to focus a little more on graphs of functions. So remember, when you look at a graph to determine whether it's a function or not, you can do the vertical line test. And then let's talk about all the properties we can about a graph of a function. So let's start with the domain and the range. So when you're looking at a graph and you want to find the domain, you're looking for all the possible input values. And think about that as the x values, all the possible x values. So when you look at the graph, you want to see how far left does this graph go? And if we see that this very last point is at -5 on the left. And then we think about how far right does the graph go? Because this guy has an arrow that says go forever, it keeps going forever and ever and ever and ever and ever to the right. So the domain of this function starts at -5 and goes forever to positive infinity. Because remember, we're using the x values, and the x's are getting bigger. The y is going to negative infinity, but the x is going towards positive infinity. If you remember from your interval notation, the infinities and negative infinities always get parentheses. And we're going to write these in interval notation. And we're looking at this very first point where we started. It's a filled in circle, so we get a bracket there at the filled in circle. Okay, so now we're going to start again, and we're going to try to do the range. And the range is all the possible outputs, or the y values. And when you do that, you want to read from bottom to top, okay? So this graph goes down, 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 down forever, and it never, ever stops. Down here, the y's are at negative infinity, okay? And then it goes up, 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 up until it reaches the top here at 5, because that point is the very top there. So the range of this graph is the bottom, negative infinity, it goes down forever, to 5 at the top. And remember, infinities and negative infinities always get parentheses. This guy comes from this point right here, that 5, the y value of 5 comes from that point there. Because it's a filled in circle, it gets a bracket. So for this graph, the domain is the interval -5 to positive infinity, and the range is the interval -infinity to 5. Okay, so let's talk about lots and lots and lots of properties of a graph. So x and y intercept, we've seen those before. The x-intercept is the place where it crosses or touches the x-axis. The y-intercept is the place where it crosses or touches the y-axis. The domain and range, that's what we just talked about, the set of all inputs or x values. And again, we read from left to right. The range is the outputs or the y values from bottom to top. Increasing, you want to think about places where the graph is sloping upwards like that. Decreasing, going down, and constant is going to be horizontal. And we always read from left to right. So you're moving from left to right. If their y values are getting bigger, it's increasing. If they're getting smaller, it's decreasing. And if they're staying the same, it's constant or horizontal. All of these things are written in interval notation. Okay, maximums and minimums. So we're going to talk about two kinds of maximums and minimums. A relative or local maximum or a relative or a local minimum is any place where the graph changes from increasing to decreasing or decreasing to increasing. Kind of think of maximums as tops of hills and minimums as bottoms or valleys. Now, you do not have to be the biggest point in the whole graph. You just have to be bigger than the pieces around you. Compared to the absolute or the global, and that's going to be the highest and lowest point on the entire graph. And these are just going to be points, okay? You're going to see they're going to ask you these questions in different ways. They're going to say, where is the relative maximum or global? When they use the words where, they want x values. What or value is y values. So they'll say, where does the maximum occur? Or what is the maximum value? When they say where, you give them an x. When they say what, you give them a y. Otherwise, you could give a point. So let's try to do that for a graph. So here's a graph. And we're going to try to find all of these characteristics about this graph. First, we're going to find the values of x for which f of x equals negative 50. So remember, this is an output or a y. So we're going to go to negative 50 on the y. And we see that there looks to be 3 places where the y value is negative 50. At x equals negative 6, x equals 2, or x equals 4. So there are 3 x values where the y is negative 50. Okay, the second part says, is f of negative 1 positive or negative? Remember, if it's inside the parentheses, it's the input or the x. So I'm going to go to x equals negative 1, which is about here. I see that the output value is right there. Looks to be around like 40 maybe. And it's a positive number because it's above the x-axis. F of negative 1 is about 40. Okay, now it says, what is the domain? Remember, the domain is going to be an interval notation, and we go from left to right. So if we go as far left as we can, it looks like it starts here at negative 8. If we go as far right as we can, it looks like it stops there at positive 8. Maybe that's positive 7. Let's see. Oh yeah, let's make that positive 7. Negative 8 to positive 7. So the domain is going to be negative 8 to positive 7. Both of these are filled in circles, so they get brackets when we write them. There's no breaks or holes in the middle, so I'm going to use that whole interval from negative 8 to positive 7. Okay, range. When we do the range, we go from bottom to top. So the bottom of the function is down here. It looks like at negative 210 or something. The top of the function is up there. It goes all the way in between. So let's say like negative 210 all the way up to 150. Again, the bottom point is a filled in circle. The top point is a filled in circle. So they're going to get some brackets. Okay. X-intercepts. X-intercepts were places where the graph touches or crosses the x-axis. So I see this graph crossing the x-axis at 3 different places. I would say x equals negative 5, x equals 0, and x equals 5. Y-intercepts, that's where it touches or crosses the y-axis. That happens at just one place, y equals 0. Okay, relative maximums and minimums. So those are tops and bottoms of hills. So here's one. This is a maximum. It's a top. And here's another one. It's a minimum because it's a bottom. So we would say max at, let's see, negative 3 comma 50. Min 3 comma negative 50. It looks like. Okay, absolute. So these were just relatives, because they're not the biggest pieces in the whole graph. They're just bigger than the places around them. Absolute. So where's the highest point in the whole graph? Over here. This is an absolute max. And then the lowest point in the whole graph? Over here. An absolute min. So we're going to say the absolute max is at 7 comma 150. And the absolute min is at negative 8 comma negative 210. Okay, so if we're walking from left to right on this graph, what's happening? Well, we're climbing up the hill from negative 8 until negative 3. So from negative 8 until negative 3, we're climbing up the hill. From negative 3 to positive 3, we're going down the hill. And then from positive 3 until 7, we're going back up. So when we're going up, we're increasing. And these are x values, okay? So we're increasing from negative 8 to negative 3 and from 3 to 7. These were these 2 places where the graph was going up. We're decreasing from negative 3 to positive 3. That was that one place where the graph was going down. And we're never constant. We don't have any flat parts of this graph.